Hi guys, this is Miss Gold. Today's lesson is Module 1, Lesson 3, Identifying Proportional and Non-Proportional Relationships in Graphs. Your outcomes for today are students decide whether two quantities are proportional to each other by graphing on a coordinate plane and observing whether the graph is a straight line through the origin. Students study examples of quantities that are proportional to each other as well as those that are not. For example 1, what I'd actually like you to do is first start by pausing the video, and I want you to answer this question based on your knowledge from the previous lesson. So go ahead and pause the video and continue when you are ready. All right, so looking at this example, what you should have done is take our knowledge from yesterday, which is to look at the table and identify what is being multiplied to get the output. Now, it's not as clear in this situation. You'll notice that we don't know what you multiply 2 by to get 3 right off the top of our head. So you want to use that strategy where you take the output and divide it by the input. In this case, it is going to be the money is the output and the number of candy bars sold is the input. So if we take our output here, the original one was 3, and we divide it by 2, now this works out to be 1.5. And we want to test all of them, so let's go ahead and do that. Let's see, output 6, input 4, that gives us 1.5 as well. Okay, so we're off to a good start. We have 9 as an output and 6 as an input. Divide those two, you're going to get 1.5. And the last one, 12 is the output, 8 is the input, and that also gives us 1.5. Since they're all being multiplied by 1.5, that should tell us that this is a proportional relationship. So we'll answer our question. Yes. And I'm realizing as I'm writing this that this is going to be a cost per candy bar. So instead of writing 1.5, I'm going to write it as $1.50. And notice that this makes sense. You wouldn't sell candy bars and charge one person one amount and another person a different amount. So we know that this is a proportional relationship. Now let's take that same table and plot each of these points on a graph. Now I already have a graph set up for us. We have these sides labeled. So we have this axis here is our X. This is our Y over here, and they're labeled going up by units of 1. So if we plot our points here, notice whenever you plot this, the X is going to go on the X-axis here. So I'm going to start at the origin and go over 2. And then my Y is 3. So from there, I'm going to move up 3. And so that's going to be my first point right there. The next one is 4, 6. So again, I move over to 4 and up to 6. Next one is 6, 9. So I'm going to go over 6 and up 9. And then we have 8, 12. So I'm going to move over 8 and up to 12. So let's take a look at what graph we have created. You'll notice here that as you look at this, there's 2 important characteristics that you should know about this graph. I noticed 2 things. The first thing is, if I were to draw a line to connect these points, so let's sketch one, let's see. I noticed that this line would look something like this. And in fact, you can see when I do a straight line here that those points actually do connect. And so it forms a straight line. So that's the first thing I notice. The points lie on a line. The second thing I notice is that this graph starts at the origin, or 0, 0. So right here, this is known as the origin. We might want to make that note. and you should recall that from previous grades. So the line goes through the origin. And these are actually the two main characteristics of proportional graphs. So you can plot points from a table on a graph and take a look at the points and what they form. If the points lie in a line and they go through the origin, that is going to be a proportional graph. So write proportional. Let's take a look at example 2. So I'm going to do the same thing. I'm going to plot my points. I have 2, 3, 4, 6, 8, 12, and 12, 14. So I'm going to take out my straight edge and I'm going to see if this works. If I'm going to be able to start at the center and go up. And when you draw that line there, you should notice that this point here does not fall on that line. In fact, let's do that in a different color. This point doesn't fall on our line. And since every single point does not fall in the line and start at the origin, that tells us that this is not a proportional relationship. So it starts So since it starts at the origin, but it is not a line, if it fails to achieve one of those two outcomes, it's not proportional. And by the way, these 3 little dots that are in a triangle, that's shorthand for therefore. Okay, let's take a look at one more example. If we start with plotting our points, first one is 0, 6. Then we have 3, 9, and 6, 12, 9, 15, and 12, 18. Okay, so I'm going to get out my tool here and draw a straight line. Now you'll notice that when I draw this one, it does form a straight line. However, it fails the other element. It doesn't start at the origin. So we'll point out that there is nothing down here. It doesn't start at the origin. So we can say that this is a line, but doesn't start at the origin. So therefore, this is also a non-proportional relationship. In today's lesson, you have learned that when two proportional quantities are graphed on a coordinate plane, the points lie on a straight line that passes through the origin.